Okay, yes, welcome to your third science lesson. We are still looking at light, so we have learned how it travels in straight lines, okay, how it can be reflected and that the angles of incidence and the angles of reflection are equal, and that the normal line on that diagram goes to 90 degrees, okay, so it's a right angle. And then today we are going to be looking at the words translucent, transparent and opaque and refraction. Okay, so by the end of this lesson you should know what they mean. So you're going to investigate how refraction changes the direction in which light travels. Okay, so we looked at this a little bit last week in terms of reflecting it and changing the way that light travels, and now we're going to look at actually that's called refraction. Okay, so there's refraction and reflection. Try not to mix them up. So you need to understand how light is refracted, you can investigate the effects of refraction, and you can understand the way refraction alters the direction of light. Okay, so here's a little riddle. This photo shows the effect created when light is refracted. Okay, so you can see the straw and then it looks like it's bent when it hits the water, and then it continues to travel in a straight line. Okay, so you can imagine that this water here is the object that light is traveling through, and when it hits it, it changes the direction because it slows the speed that light can travel, so it has to change direction, and then once it gets back it can continue to travel at that speed. Okay, so that is what is happening. So the children are talking about why the straw looks broken when they know it isn't. Who do you agree with and why? So think about what I've just said and then look at who you agree with. I think the water has bent the straw so it looks like it has broken. Light travels at different speeds through water and glass, making the ray of light bend. This makes the straw look bent or broken. The light can't travel through the glass properly and the ray of light is broken. This makes the straw look broken. The straw is opaque and the glass is transparent, which causes light to be twisted, making the straw look bent and broken. So you can pause and have a read of those again and then decide which one you are going with. Here are some examples of refraction in the real world. So you can see the glass ball, okay, and you can see the rainbow, the colours of the rainbow. That is actually light. So light is made up of the colours of the rainbow, but we just see one white light. So white is actually made of red, orange, yellow, green, blue, indigo, violet, the colours of the rainbow. Okay, so let's have a look. Let's look at the definition of refraction. What do we say? What do we mean when we say refraction? So light waves travel at different speeds, okay? So when they go through other transparent materials such as water or glass. Don't worry if you're not sure about what that word transparent means, we will come to that later, okay? This causes the rays of light to change direction and bend, which is known as refraction. So refraction is very simply is the bending of rays of light, okay? So refraction is the bending of rays of light, all right? Now that's to do with changing the speed at which light travels through an object, okay? So refraction creates illusions like you can see at the side there because light bends when it travels between air and water or glass. Objects seen through these materials look bent or distorted. So if you have maybe a coloured plastic cup at home and you have put some liquid in and you try to look through it, maybe there's a person at the other side, they will look a little bit distorted, they'll look a little bit weird compared to if you looked through when there was no liquid in. Okay, so we can't work together to set up this investigation, but there are links in your resources that you can watch and you can have a go at home if you can. So we're going to look at the investigation and we're going to predict what can happen. Now you can do these at home if you can. If not, don't worry, we can just look at the predictions. So if you can, we're going to draw a horizontal arrow on a small piece of paper and then you're going to hold the paper behind a glass filled with water. What do you think is going to happen? Okay, try it out, try and describe your observations and see if you were accurate, okay? So, for example, I think that the arrow will look distorted because light will bend once it travels through water, as it can't travel as fast through water as it travels in air, and so it will be refracted, it will bend and change direction. See if I'm right, year 6. Okay, so you can draw a picture on a piece of paper. It could just be something really simple like a smiley face or a star, all right? Then you're going to place an empty glass over the top of the picture and look at your image, all right? And then as you watch your picture, you're going to fill the glass with water. Maybe you could get an adult to help you with this, okay? When the glass is full, cover the top of the glass with a saucer and predict what you think will happen, okay? Record your observations, all right, and see if you can explain why it's happened. So can you use that word refraction? Can you use the bending of light? See what happens. So when you place an arrow at a certain distance behind the glass of the water, it appears to point in the opposite direction. The arrow turns because the light travelled from the air through the glass, through the water, through the back of the glass, and then back through the air, hit before hitting the arrow. When light passes from air through a transparent material, it refracts, causing it to bend. So you can see this diagram here of where it's travelled. Okay, and the arrow looks like it's facing in the opposite direction because the light has been refracted. Okay, very simply. So because the glass is curved, that acts as a lens. Think about if you wear glasses, you have lenses in your glasses. So your drinking glass acts as a lens, focusing the rays of light. Okay, and where light comes together, that's called the focal point, which you can see labelled on the diagram below. But beyond the focal point, the image appears to reverse, okay, because of that refraction of light, okay. Don't worry if they find this complicated. As long as you understand that refraction is the bending of light, you don't need to worry about the arrow. Okay, let's have a look at this. When you fill the glass with water and place the saucer on top, the image seemed to have disappeared. Light rays falling on the image are refracted through the glass, so they're bent through the glass, then the water, and then back into the air. So that's how many times they change and bend because of the speed. When the refracted rays are bent at different angles by adding the water, it means they can be blocked by the saucer on top of the glass. So the rays of light can't get through the saucer. They can't reach our eyes, so we can't see the image, even though it's still there. You haven't ripped it out, it hasn't disappeared, it's still there. Okay, so looking at transparent, translucent and opaque now, because we're looking at rays of light travelling through objects now. They travel at different speeds through different objects, and it depends on whether that object is transparent, translucent or opaque. So we're going to go through what those words mean now. So you're going to have to investigate how refraction changes the direction in which light travels. Okay, so it's the same success criteria. So transparent. If an object is transparent, it means light completely passes through it and you can see clearly. Thinking about your glasses, be no good if they weren't transparent because they're supposed to help you to see. Okay. Translucent. Now, if an object is translucent, it means that some light passes through it, but the light is scattered so you can't see clearly. So things like coloured glasses, we have a lot of coloured paper that's slightly see-through, you know, like not like tissue paper, but that would be one, but almost like crepe paper. All right, and that is translucent. So it's not fully transparent, you can't fully see through it, but it doesn't block all the light either. So you've guessed it, opaque is if an object is opaque, it means that no light can pass through it, it blocks the light. So think about our desks in our classroom, it blocks the light. Think about your curtains, they're going to have to be quite opaque. All right, some people have blackout curtains which are very opaque, which means they let no light through so you can have a good night's sleep. Other people prefer translucent curtains where the material is slightly see-through so it's not too dark in the room. All right, or chairs. A lot of chairs aren't translucent or transparent, they're opaque. They let no light pass through so it blocks it. So look at these objects and decide if they're translucent, transparent or opaque. A window. What do you think? I'm gonna go with transparent. Absolutely, yeah. A window has to be transparent or it will let no light in and we'll have very dark houses. Sunglasses, what do you reckon? translucent. See, they have to let some light through or we wouldn't be able to see, but the whole point of sunglasses is that they block some of the sun's rays so we're not squinting as much. A book, what do you think? Yep, opaque, a book does not let any light through whatsoever. Ice cubes, what do you think? Let's go with transparent. Ooh, not transparent, what do you think? Yeah, they're translucent, so you might think they're transparent, okay, but they don't let all the light through. Yeah, water isn't completely crystal clear. A glass jar. Ooh, so don't be fooled, it's not the same as the ice. Yeah, completely transparent, lets all the light through. A coat. Yeah, easy peasy, opaque, doesn't let any light through. A lampshade. Again, it's going to let some light through, otherwise there's no point in having a lamp on, is there? But it's not going to let all the light through. An apple. Yeah. A bottle of water. Ooh. Yeah, transparent. Okay. Now the if light was to travel, the water would still it would change speed, so it would still be refracted, but it does let all the light through. Okay, so don't be fooled. Table. We talked about this. Stained glass window. Yeah, so stained glass windows got to be translucent because it still lets light in it, and if you've ever been to a church, it looks beautiful with all the colours when the sun's shining through it. Okay, so your task. Now you've got these videos to watch, which are in your resources folder, okay? And you're going to shine a torch through a range of different materials, and you've got a table as well in that resources section that you can record the material and whether it is translucent, transparent or opaque, okay? Now that you know what those mean. And this is the table, okay? It's in your resources section along with the links as well to watch the videos just in case. So shining a light through some materials can change the light's direction. So you can watch the video clip which explains this further. So I know I've explained it in this lesson, but you've also got a video clip to help your understanding as well. Okay, now remember light travels back into the eye so we can see. Remember we looked at where light travelled to at the very start of the lesson, to the object and then the eye so that we can see it. Okay, so your tasks. Green, you're going to use words and diagrams to show what happens when light is refracted. You can present this any way you want, okay? Your blues, you are going to discuss how light changes direction. So think about that scientific vocabulary. Can you also look at light speed? Can you think about refraction? Can you think about what materials get refracted, whether it's translucent, transparent and opaque? Can you maybe describe what all those words are? All right. And then reds, shine a torch through a range of different objects. Take note of the angle that it goes in and the angle that it goes out. So building on the angle of incidence and the angle of reflection, last week, can you then look at, well, is the angle of refraction different to the angle of reflection? Okay. Well done, year 6. Keep working hard.